In this data structure class, we will see the insertion sort from third unit, searching and sorting. And in today's class, we will see the definition of insertion sort and let us see the algorithm. After that, we will solve some of the examples by using insertion sort, and finally, we will see the advantage and disadvantages of insertion sort. First, let us see the definition of insertion sort. So, the insertion sort is used to order the list of values iteratively, inserting a particular value into the sorted subset of the list, that is left side of existing value as per the following step. So initially we have a list of unsorted data values. At every iteration, the first value will be inserted in its right position. Okay, at every iteration, the first value will be inserted into the right position. Hence, at every iteration, the sorted array will get incremented by 1 and the unsorted array will be decremented by 1. Okay. See, the steps are: first, let us take the first item from the unsorted array and that will be stored in the sorted array. Okay. When come to second one, we can take the second item from the unsorted array and that will be placed in the sorted array, and shifting may be possible if it is required. That means the second item is less than the first item, then we can shift to the data items. Otherwise, no need. Okay. Likewise, we have to take the third item from the unsorted array to the sorted one. Okay. The same steps will be repeated until all the values are inserted into the proper positions in the sorted data items. Okay, here the grayscale represent the sorted array and the colors are represent the unsorted array. Okay, here the insertion sort is a very simple sorting algorithm and it requires n minus 1 passes over the array. For example, if we have 10 data items to be sorted, then it requires 9 passes or 9 iterations required to sort all the 10 data items. Okay, that means at the end of pass I, the data elements A0 to AI are in sorted order. For example, at the end of pass 5, 6 data items to be sorted in the order. Okay, because the index starts from 0. Okay, 0 to 5 means totally 6 number of items to be in the sorted order. Okay, initially the data items are available in the unsorted array. At every pass, one data item that will be taken and that will be placed in the unsorted, that is sorted array. So this is sorted array and this is unsorted array. Okay, at every pass, this particular item, that is the first item, will be removed from unsorted array and that will be stored in the sorted array in its right place. In its right place. Okay, how many pass it required? It required n minus 1 passes to sort all the data items in the array, right? The idea behind this insertion sort is playing cards. Okay, now we have a set of cards in our left hand and we need to insert a new card which is in our right hand. Okay, which is in our right hand. Now we need to insert this new card into uh, this set of cards, right? Here, the new card into the correct position. We have to insert the new card into the correct position in the left hand side. Then how we are going to insert? First, compare this new card with each of the cards already there in our hand from right to left. This is important. Okay, because we are inserting this card from right hand, so we have to compare the values from right to left. Okay, now we need to insert the card 12. We need to insert the card 12 and we have to make a room for this 12 by moving 36 and 24. Then only we have to insert 12, right? First, this 12 will be compared with 36. 12 is less than 36, hence the 36 will move towards the right side so that it will create some place for holding this 12 here. Okay, and then 12 will be compared with the next card. Here 12 is less than 24, isn't it? Then 24 should be moved towards the right side so that it will create some space for this 12. And now this 12 is compared with the 10, but 12 is greater than 10, then this is the right place for the card 12. Okay, so the card 12 will be inserted in this shape. Now the 12 that is the card 12 is placed in its right location. Okay, that means at every iteration the new card will be placed in its right position, okay, that is inserted in the right position. Hence the sorting is called a insertion sort. This is another example. At every iteration, one element is taken from unsorted array and that will be compared with all the sorted array from right to left. Right to left. Okay. If it finds its right place, then the data item will be inserted in its right position in the sorted region. In the sorted region. Okay. This is example 2. Sort the given set of numbers using insertion sort. The given numbers are 23, 78, 45, 8, 32 and 56. So here n equal to 6, isn't it? So totally 6 number of items are there. The starting index is 0 and ending index is 5. Okay. So this is 0, 1, 2, 3, 4, 5. Okay. So this is the original list. In the original list, the 23 is placed in its right position. That is the first item is placed in its right position. And the second data item. Second is 78. Okay. When compared to 23, 78 is bigger. So it will place uh, before 23. So at pass 1, two data items are placed in its right position. And when come to pass 2, the third data item will be taken. So the third one is 45, right? See 45, when compared to 78, 45 is smaller. So it will create one room for 45 and 45 is greater than 23. So 45 will be inserted in between 23 and 78. Okay, so this is path 2. When come to path 3, the value 8, the 8 will be placed in the first position. Okay, because this is the minimum value. Okay, so at the end of path 3, 4 items got sorted. And next one is 32. 32, that will be placed in between 23 and 45. Okay, so the 78 and 45 will be moved towards right, and in that place 32 will be located. Okay, and finally the value 56. So the 56 will be stored, that is before 78 and after 45. So in this place, this is the place for 56. So at the end of pass 5, all the 6 data items will get sorted. Okay, so this is called as insertion sort. And this is the algorithm for insertion sort. The function insertion sort has one parameter, that is array of unsorted data items. Array of unsorted data items. The for loop, it is having one counter variable, that is I equal to 1, I less than a dot length, I plus plus, right? So this length is represent the size of array. Size of array. For example, the array size is 6, then how many times this for loop will executed? 5 times, because the index starts from 1, say 1 to 5. Okay, and the temporary variable which is used to hold the first value of the unsorted data item. Unsorted array. Okay, And another counter is there, that is J, and this is used to compare the data item with the sorted array. Sorted array. Okay. See, the gray color is sorted, and the colored item is unsorted. Okay. See, the data item will be compared with last item to first item. Okay. See, if the temporary is greater than a of j minus 1, then these two data items will be exchanged or swapped, and j will be decremented by 1. Okay, and finally, the temp value will get its right place in the sorted array. Okay, so this is what the algorithm for insertion sort. And now let us see the advantages of insertion sort. The insertion sort gives best performance when compared to the previous sorting algorithms like bubble sort and the selection sort. Okay, and it is efficient for smaller data sets. Very easily it can sort the smaller data set unsorted items, and it requires very less memory, that is order of 1, and it requires, that is, it works well with the data set which have already sorted. Okay, if the data set is already sorted, then it will produce a very best result, and it does not affect the relative order, the elements which has same keys. Okay, suppose if similar numbers are occurred, then it will not affect, the sorting will not affect. Okay, so these are the advantages of insertion sort. Next, let us see the disadvantages of insertion sort. The insertion sort is suitable only for smaller data sets. If the data set is expensive, then it is inefficient. Okay, and in the worst case, time complexity is order of n square. That is, it takes more time if the data set is reversely ordered. Okay, and it does not perform well when compared to more advanced sorting algorithms. For example, quicksort and heap sort, the performance of insertion sort is very low. So these are some of the drawbacks of insertion sort. So far we have seen the insertion sort from third unit, searching and sorting. Here we have learned the definition of insertion sort, algorithm with examples, and finally we have seen the advantages and the drawbacks of insertion sort. In the next class we will see the merge sort. Okay, thank you.